Hello, my dear students. I hope you guys have been coping up with the previous videos and that you understood everything about functions. What are functions, and what is the condition for a relationship to be called a function? Um, because today we will be discussing about something known as domain and range. Of course, this is the carry on of the topic of functions. Now, what do we mean by domain and range? This is something I'm going to discuss, and then I'm going to discuss the three ways in which you're going to find domain and range represented. So let's look at what is domain and range. What do we mean by domain in terms of the definition? So whenever someone asks you what is the domain, generally domain is defined as all possible x values which give the function an output. Give the function okay, let me say outputs because all the inputs have different outputs. Let's look at this with an example of what do I mean by this. Okay, some of you might be scratching your head, so we're gonna come to an example. Let's say, guys, for example, I have f of x is equal to 1 over x minus 1. What I want you guys to analyze is that this is a fraction with a numerator and denominator. Whenever the denominator is 0, okay, the function would be undefined. We cannot have an output for this function when the denominator is 0. X minus 1, okay, cannot be equal to 0 because x minus 1 is the denominator. Now let me find the value of x which will make this function undefined. So can I say that x minus 1 equals 0, and then when x is 1, the denominator is 0. For this function, we can say that x can have all values except 1. Okay, I'm gonna come to how we will represent this in one of these forms in shortly. Now, what is the range, guys? The range itself tells you by the word all possible output values okay. Now the range depends on the input. Okay, the range depends on the different inputs. Okay, I hope there is no confusion in this. Simply all possible output values. Let's try to sort of come up with some inputs and outputs for this function. I would need space, so I'm going to start here. So I have f of x is equal to 1 over x minus 1. We already know that x cannot be 1. We already know that by now. Now let me take a random value of x, such for example f of minus 2. So I have 1 over minus 2 minus 1, which will give me minus 1 over 3. Okay, Now let me take another one, f of minus 3. I would have 1 over minus 3 minus 1, which will give me minus 1 by 4, right? Now, let me take some value on the right of 1. So let's say, or greater than 1. So f of 2, 1 over 2 minus 1, which is 1. And then f of 3, 1 over 3 minus 1, which is 1 by 2. Right? Now guys, if you focus here, let me erase this part to show you guys something. To help us understand, I'm going to make a sketch of the graph. So you have the 0 here, 1, 2, 3, negative 1, negative 2, negative 3, and then you have the y scale, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, we know that x cannot be 1, so there is no way we won't have any output here. Let me draw that with a different color. So there is no way we will have an output when x is 1. Now when x is negative 2, we have negative 1 by 3, which is, so x is negative 2, right? Negative 1 by 3 would be somewhere here, okay? Less than negative 0.5. And then you have, when x is negative 3, we have f of x is negative 1 by 4. So at negative 3, we have negative 1 by 4. Somewhere here, right? This graph would be somewhat, let me try to extend it. When x is negative 1, it's going to be negative half. So it's going to be somewhere here. So this is somewhat how this graph would look like. Now let me take the right side. When x is 2, so the f of x is 1. So at 2, it's 1. When x is 3, f of x is 1 by 2. It's going to be 1 by 2. It's going to be a bit above. Okay? And then so on. When x would be 4, it's going to become 1 over 4 minus 1, which is 1 over 3, which is even smaller than this. So it's going to be like this. Somewhat, right? Now if you guys notice something here, that this graph is going to come from negative infinity and it will be below 0. Always the range would be below 0. And then it's going to go above 0, and again as we are increasing with the positive values, it's going to approach 0, right? So let me write down the domain and range of, so let me erase this part, because since we have a graph now, So let's first write down the domain of this function. The domain, we know that all values of x are possible except 1. So I can write it, for example, now let me take an example. Let me write it in interval notation. Now how does interval notation look like? Interval notation uses brackets to basically show the edge values or the endpoints, I'm sorry, and square brackets to show that the endpoints are included. So now there are two scenarios. One is when the endpoint is included, that's when you use a square bracket. One is when the endpoint is not included. Let's see what I mean. So the domain is negative infinity, okay? So it's coming from negative infinity all the way before 1. 1 is excluded. Therefore, I'm going to write negative infinity, comma 1 with a bracket, not a square bracket. Union, again, above 1 until infinity. Again, you're going to use bracket, not a square bracket. Now, generally, the rule of mathematics is that whenever you have negative infinity or infinity, you will always use a bracket. Okay, negative infinity and infinity are not included. Okay, now let's move on to the range. As you can see, that this graph to me is coming above from negative infinity below 0. So I can write negative infinity and then 0 excluded, not included, because these values, this graph will never intersect the x-axis. It will be very close but never intersect. Okay, now, and then you have another range starting from somewhere over, let's see, so you have, it's approaching 0 from infinity. So I can say 0 to infinity. Okay, I'm just writing in an order from these two values. Again, I said whenever you use infinity or negative infinity, it will always have a square bracket. Bracket. Now, this 0 is not included, that's why I used a bracket again. If this 0 was included, then we would be using a square bracket, right? I hope this is clear, guys, and in the next video, I would be continuing on the other two ways to write down the domain and range. Okay, these are just different representations. Okay, there's nothing to worry about in this. And then you can always email me at prof_mahad mahad@hotmail.com if you have any questions, if you need any online or in-person sessions. Thank you so much, guys, for watching, and do subscribe, because from now on we're gonna have regular videos and we're gonna be progressing step by step. Thank you so much, guys, for watching, and do post if you have any question. I would be more than happy to assist you. Thank you so much. If I can't assist you in the comments, I can always reply to your emails. Thank you very much, and goodbye for now.